Hi friends, good evening. Welcome to my channel, Belagali's class. Friends, I have started doing examples under 1 mark and 2 mark. Examples under 1 mark and 2 mark. I have started with the separate chapters. In the beginning, considered inverse trigonometric functions. On that, I have done 2 videos. One video under 1 mark question and second is under 2 mark question. After completion of what? Examples on inverse trigonometric functions, I started with calculus, that too differentiation. My friends, 2 videos I have done with 1 mark question, and third video I have started with what? On differentiation, examples under 2 mark questions. Again today, one day, just one full video or this class, I am going to do with what? 2 mark questions only. Yes, my friends. Now I will start with, I will continue with 2 mark questions, differentiation, 2 mark questions. Yes, my friends. Once again, it is a PUC second year or 12th standard maths class, mainly with the differentiation. These are 2 mark questions on implicit functions, my friends. 2 mark questions on implicit functions. Already, my friends, you have everything. I have done already videos on implicit function, differentiation of implicit functions. In that video, I have explained what to mean by explicit function and what to mean by implicit function. Then, given the rules to differentiate implicit functions, and I have done examples, all these examples under 2 mark, 3 mark, only 2 mark and 3 mark. No chance of getting what? 5 mark questions. Only 2 and 3 mark questions on implicit. Yes, my friends. 2. One is explicit. Yes, we have done so far examples on what? Differentiating a function where your variable y is purely expressed. Your variable y is purely expressed in terms of x. Like what? My friends, fx. Here, y, this is the dependent variable. Dependent variable is expressed purely in terms of independent variable. There are 2 variables, my friends, x and y. These are the 2 variables. X and y are the 2 variables. One case, y can be expressed purely in terms of x. If you write like this, it is called as y is an explicit function of x. What is another one? There are functions where y can't be expressed. Y can't be expressed in terms of what? X. They are connected. X and y are connected. We can't do y one side and function of x other side. Like this, we can't express. In that case, here y is said to be implicit function of x. Y is said to be implicit. Can be expressed. Y is a explicit function of x. Y can't be expressed in terms of x. They are connected. In that case, this y is said to be implicit function of x. Yes, my friends. This is about implicit and explicit functions. Implicit and explicit. Hope understood. Yes. First, these are 2 mark questions on implicit functions. I am going to do first some examples, my friends, from your exercise 5.3. Rules to find dy by dx in case of implicit function f of xy equal to 0, where y can't be expressed purely in terms of x. I explained here, my friends. When y can't be expressed in terms of x, in that case, y is said to be implicit function of x. Definition. Next. I have started here with the rules only. First, rule 1. Differentiate the given function with respect to x. First, differentiate the given function with respect to x. This is rule 1. Rule 2. After differentiating the given function, separate, my friends. Collect the terms containing dy by dx on one side, say LHS, and free from dy by dx. Free means what? They are free from dy by dx. On other side, say RHS. There are two terms containing dy by dx, terms not containing dy by dx. Terms containing dy by dx on one side, terms not containing dy by dx on other side. One side, other side. This is second rule. Third rule, simplify and solve for dy by dx. Simplify the things here into, then you solve for dy by dx. Solving for dy by dx, you get the value of dy by dx. In doing the examples on implicit, I already told this. Yesterday I done examples based on this. While differentiating any function of y, what is fy? Any function of y with respect to x. First, differentiate function of y with respect to y, then y with respect to x. Differentiate function of y with respect to y, then differentiate y with respect to x. Derivative of y with respect to x is dy by dx. This is second note. Results are just reminding my friends. Derivative of ku plus minus p. What about u and v? They are the functions of x. U and v are functions of x. Constant coefficient remains as it is. K into derivative of u with respect to x. Derivative of u with respect to x. Plus is plus, minus is minus. Then derivative of v with respect to x. This is a product formula. Derivative of u v. This is first function into derivative of second function plus second function into derivative of first function. First into derivative of second plus second into derivative of first. Yes, my friends, it is a product rule. This is algebra, means what? Plus and minus. Constant with a coefficient. Yes, my friends. We are applying all this while doing the examples. See, examples are here. Examples are here. Find dy by dx of the following. Find dy by dx of the following. This is first example, which is a solved example in your textbook. Solved example. Y plus sin y equal to cos x. Y plus sin y equal to cos x. Differentiate with respect to x. Derivative of first, I have written, this is a supportive steps, my friends. Supportive steps. Otherwise, if you wanted, you can write directly this step. Support, if anybody is perfect, directly write. Otherwise, take the help of supportive step. Derivative of y with respect to x, plus is plus. Derivative of second function is sin y with respect to x equal to derivative of RHS cos x with respect to x. Derivative of y with respect to x is dy by dx. What is this, my friends? Other than x, first differentiate sin y with respect to y. Derivative of sin y with respect to y is cos y, then derivative of y with respect to x. Remember, my friends, while differentiating any function of y here, any function of y, it is a function of y other than x, any function of y with respect to x, this dy by dx into dy by dx. First differentiate this function with respect to y, then into dy by dx, y with respect to x, y with respect to x. Yes. Sin y, first with respect to y, then y with respect to x equal to derivative of cos, I said c means sign change, minus sin x. Dy by dx is common. 1 plus cos y into dy by dx equal to minus sin x. I told solve for dy by dx minus sin x upon 1 plus cos y. This is dy by dx. Yes, what is the first rule? This is a given function. First rule, differentiate with respect to x as it is. Differentiate this. Derivative of first, derivative of second, derivative of RHS. Write their derivative. Derivative of y is dy by dx plus sin y, cos y into derivative of y with respect to x, cos x minus sin x. Simplify. What is the simplification here? Dy by dx is common. 1 plus cos y equal to minus sin x. So dy by dx is minus sin x upon 1 plus cos y. This is first example. This is second example. 2x plus 3y equal to sin x. Commonly I have written find dy by dx. First step, first rule, differentiate with respect to x. Derivative of LHS, derivative of RHS. Derivative of kx is k, kx is k, 2x is 2 into derivative of x is 1 plus 3 into derivative of y with respect to x is dy by dx equal to derivative of sin x is cos x. Then you have to simplify 3 into dy by dx equal to cos x minus 2. Solve for dy by dx. Cos x minus 2 upon 3 is dy by dx. Then this is a third example, my friends. Third example. 2x plus 3y equal to sin y. First rule, differentiate with respect to x. Derivative of LHS equal to derivative of RHS. 2 into derivative of x is 1 plus 3 into derivative of y is dy by dx. This step, my friend, equal to sin y. First with respect to y, then y with respect to x. You have to simplify it. Collect dy by dx on one side. Terms containing dy by dx one side. Free other side, other side. Simplify. Dy by dx is common. Cos y minus 3 into dy by dx equal to 2. Solve for dy by dx. Bring it down. It is 2 upon cos y minus 3 is dy by dx. This is the third example, my friend. It is started here. It is started here. Yes, my friends. Copy. Copy. Yes, friends, I hope everything is clear. I have explained twice, my friends. Next, I will continue with examples. Yes, friends, the next example is ax plus by square equal to cos y. It is there in one of the model question paper, my friends. One of the model question paper and a 2-mark question. 2-mark question. Anyway, I am doing branded here, 2-mark only. No need to for every time mention. Yes, my friend. This is the given function. First step, differentiate with respect to x. Derivative of first term plus derivative of second term equal to derivative of RHS. This a and b being a constant coefficients, I have written outside derivative sign. A and b are constants coefficients. I have written outside derivative sign. A into derivative of x plus b into derivative of y square equal to derivative of cos y. Derivative of x with respect to x is 1 plus b into y square 2y. First y square with respect to y, then y with respect to x. If it is other than y into dy by dx comes, my friends. First with respect to y, 2y into dy by dx. Same. Cos y minus sin y into dy by dx. Collect dy by dx on one side. It is there 2 by into dy by dx. It is a term containing dy by dx. It is shift to the LHS here, bring here, that minus becomes plus. This is free from dy by dx. Shift this to the RHS. Dy by dx is common. You have 2by plus sin y into dy by dx equal to minus 8. What is the last step? Solve for dy by dx. It is minus a upon 2by plus sin y. This will explain here once again, my friends. Given function, differentiate with respect to x. A into derivative of x plus b into derivative of y square equal to derivative of cos y. I will tell you. This is a supportive step. A into derivative of x with respect to x is 1 plus b into y square 2y into dy by dx equal to derivative of cos is minus sin y into derivative of y with respect to x is dy by dx. This collect on one side, free other side, simplify, common, the remaining you can get in the bracket. Final, solve for dy by dx minus a upon this bracket. This is the wanted dy by dx. Next is this, my friend. It is sin square x plus cos square y equal to 1. Sin square x can be written as sin x the whole square. Cos square y can be written as cos y the whole square. Differentiate with respect to x. Derivative of first term, that sin x I have written sin x to the power 2 plus d by dx of cos square y I have written cos y the whole square equal to RHS being a constant, its derivative is here. N into n minus 1, 2 minus 1 is 1 sin x into derivative of f, that is derivative of sin x with respect to x. Derivative of sin x with respect to x. Again, n into cos y 1 less n minus 1, 2 minus 1 is 1 into derivative of cos y other than x, derivative of cos y equal to 1 each here. 2 sin x, derivative of sin x is cos x plus 2 cos y into derivative of cos is minus sin y into dy by dx. Y, it is a function of y, first with respect to y, then y with respect to x. 2 sin x cos x, my friends, were trigonometric formula, multiple angle formula. Sin 2x minus with plus is minus 2 sin y cos y into dy by dx equal to 0. Sin 2x, shift to the RHS, minus becomes plus. Again 2 sin y cos y is nothing but sin 2y into dy by dx. Solve for dy by dx. Dy by dx equal to sin 2x upon sin 2y. This is the answer of our required dy by dx. Yes, my friends, this. It is also there in the model question paper. Sin square x plus cos square y equal to 1. Differentiate with respect to x, d by dx of this power I have written sin x to the power 2. Cos square y, cos y to the power 2 equal to this. 2 sin x, derivative of sin x is cos x, plus 2 cos y, derivative of cos y with respect to x. 2 sin x into derivative of sin x is cos x, plus 2 cos y into first with respect to y, then y with respect to x equal to 0. Your trigonometric formula, sin 2x, simplify, plus minus is minus, 2 sin y cos y into dy by dx equal to 0. Once again, this is nothing but sin 2y. Shift to the RHS, dy by dx. Solve for dy by dx. It is sin 2x upon sin 2y is the answer for this answer, my friend, this question. Next one. Let's copy it, my friends. Half a minute time. Half a minute, explain everything. Yes, friends. The next example is find dy by dx of x square plus xy plus y square equal to 100. All these are examples from your exercise here. Examples from the exercise 5.3 along with W means what? Worked examples. Worked examples, otherwise solved examples. Solved examples in the textbook. These are from exercise 5.3. 5.3. Yes, friend. X square plus xy plus y square equal to 100. Differentiate with respect to x. Suppurative step. Derivative of first plus derivative of second plus derivative of third equal to derivative of RHS. X square with respect to x, 2x plus product formula xy is a product of two functions. First function into derivative of y, second function. Derivative of y with respect to x is dy by dx plus y into derivative of x with respect to x. Derivative of x with respect to x is 1 plus y square 2y. Other than x means what? First you have to differentiate with respect to y, then y with respect to x equal to 0. Simplify it, collect it. X into dy by dx is one term which contains dy by dx. Other term is this plus 2y into dy by dx. Free from derivative, shift RHS. This plus y, this is free, shift to the RHS. Further, dy by dx is common. X plus 2y equal to, this minus is taken outside. You are left with 2x plus y. Therefore, dy by dx equal to, solving dy by dx equal to minus 2x plus y upon x plus 2. Yes, my friends. Correct. If you want to explain once again, this is the given example. Differentiate with respect to x. Suppurative. Derivative of first plus derivative of second plus derivative of third equal to derivative of RHS. First is x square with respect to x is 2x. X into y, product formula u v. First into derivative of second y dy by dx plus y into derivative of first x. Derivative of x with respect to x is 1. Y square implicit. First with respect to y, then y with respect to x. Y square with respect to y is 2y into dy by dx. 100 being a constant, let it be 0. Yes. Collect dy by dx one side, free other side. Dy by dx is common, x plus 2y equal to minus is common, 2x plus y. Final step, solve for dy by dx minus 2x plus y upon x plus 2y. This is the solution of our first example. Similarly, the same type, here also it contains x1. xy plus y square equal to tan x plus y. Differentiate with respect to x. Derivative of first plus derivative of second equal to derivative of RHS third plus derivative of fourth. Write their derivatives. Again it is a product formula u v x y. X into derivative of y dy by dx plus y into derivative of x with respect to x is 1 plus y square. First with respect to y, then y with respect to x. Y square with respect to y is 2y into dy by dx. Tan x derivative x square x. Derivative of y is dy by dx. Same thing. It contains dy by dx, right? It contains dy by dx, right? This contains dy by dx. Shift from RHS to LHS, this plus becomes minus. Keep it there only while free. One more is there, this is plus y. Shift that side, minus. Dy by dx is common. This equal to sec square y minus y. Solve for dy by dx. Sec square y minus y upon x plus 2y minus 1. This is, my friends, the solution of this. Solution of this on the same lines, the previous. Yes, copy it, my friends. 1 minute time. 1 minute time. Yes, friends. The next example is. Next is Example number 8. If root x plus root y equal to root a, then find dy by dx at the point 4 comma 9. At the point 4 comma 9. Given root x plus root y equal to root a, differentiate with respect to x. Derivative of first plus derivative of second equal to derivative of RHS. You know, derivative of root x is 1 by 2 root x plus first with respect to y. Root y with respect to y is 1 upon 2 root y into derivative of y with respect to x, dy by dx. Root a being a constant, its derivative is 0. In this itself, my friends, put x equal to 4 and y equal to 9. Root x, root 4, 2. Root y, root 9, 3. Substitute. 2 into root x is 2. It is 1 upon 3 into dy by dx equal to 0. This is 1 by 4, this is 1 by 6. 1 by 4 free, shift to the RHS. You are left with 1 by 6 into dy by dx equal to this plus shifted minus 1 by 4. Solve for dy by dx. Minus 1 by 4, taking 1 upon 6 that side, it becomes 6 by 1. Cancellation 2. Cancellation 3. Now it is minus 3 by 2 is the answer. Minus 3 by 2 is the answer. Hope understood, my friends. Sometimes instead of 4 and 9, the friend may give the value a by 4 comma a by 4. Both are same. Here the value of x is a by 4. This is a by 4. When both are same, it is 1 by root a by 4, 1 by root a by 4. That 1 by root a by 4 along with this 2, we can take common. We can take common. Then you are left with, what is left here? 1 itself. You are left here, dy by dx equal to 0. Then what is the value of dy by dx? Minus 1. Minus 1. Just copy it, my friends. Copy it. I write it as a note here. Note here. Copy it. This is the second example. Find dy by dx if x minus y equal to pi. It is a solved examples in the textbook, my friend. It is a solved example in the textbook. Given differentiate with respect to x. Derivative of LHS equal to derivative of RHS. X with respect to x is 1 minus derivative of y with respect to x, dy by dx. Pi being a constant, its derivative is 0. So 1 minus dy by dx is 0 means shifting this side 1 equal to dy by dx, or dy by dx is 1. Dy by dx is 1. 1. Next, my friend, 10th example. Find dy by dx if y equal to root x plus root x plus root x dash dash. It contains infinite number of terms, when RHS contains infinite number of terms. Given, while writing, I have written this x separate and remaining separate. It is what? Root x plus root x plus root x, like this, my friends. It is dash dash infinite. X plus this bracket is nothing but RHS. RHS is nothing but LHS. What is LHS, my friends? Y. So the bracket becomes, because of this y, that value of the bracket is substituted as y. So you get y equal to root x plus y. Square both sides. Y square. Square root cancels. X plus y. Bring y this side. Y square minus y equal to x. Differentiate with respect to x. Derivative of y square minus y with respect to x equal to derivative of RHS. First with respect to y square with respect to y, 2y, minus derivative of y with respect to y, 1, into dy by dx. Y function of y comes into dy by dx. Derivative of x with respect to x is 1. Solve for dy by dx. 1 upon 2y minus 1 1 upon 2y minus 1 is the derivative. Yes, my friends, here. This example at 1 by 4, otherwise a by 4, comma a by 4. Yes, here this is 1 upon 2 into root x is a by 4 plus 1 upon 2 into y a by 4 into dy by dx equal to 0. Hope this step is clear. Here it is at 4 comma 9, instead of 4 comma 9 it is a by 4 comma a by 4 or 1 by 4 comma 1 by 4, it depends upon the examiner. Then here you have to put x equal to a by 4, x coordinate, y equal to a by 4, y coordinate, both are same. Substitute x equal to a by 4, y equal to a by 4, written. Tell my friend what is common. This is 1 upon 2 root a by 4 is common. 1 upon 2 root a by 4 is common. You are left here 1. You are left here dy by dx is 0. This being a constant, taking that side, we get it as what? 1 plus dy by dx is 0. Therefore, the value of dy by dx, what is it, my friend? Minus 1 in this case. The value of dy by dx is minus 1. Note, this is the previous example is continued there. Continued. The value is minus 1. Sometimes instead of 4 comma 9, even they may give 1 by 4 comma 1 by 4. Otherwise, a by 4 comma a by 4. Whatever. If it is equal, the derivative is minus 1. Minus 1. If they are different, the value is what? Minus 3 by 2. We have done this also. I hope understood. One more I do, the same type. Yes, my friends, it is also comes under 2-mark question. Yes, friends. Next is root x plus dash infinite. Find dy by dx I have done. Instead of x I have taken sin x here. It is root sin x plus root sin x dash infinite. In this case you have to find its derivative. Given y equal to, I have separated only this first term from this. Here, how many terms are there? There are infinite number of terms, my friends. The countless number of terms are there. In that countless, if you take 1 or 2 or 10 terms or 100 terms, that doesn't matter. So in this case, I have taken first term out plus a rest I have written in this bracket. This rest is again what? It contains infinite number of terms. Then by this, it is nothing but y. Then for the bracket, I have substituted this value is y. Once again, this is the given example. While writing given, I have separated the sin x only plus the rest of the terms I have written in the bracket. My friends, this bracket is nothing but what? Given y. So y equal to, this is root sin x plus this entire thing is nothing but y. To eliminate square root, square both sides. Square y square. Square root cancelled. Sin x plus y. Bring y this side, sin x. Differentiate with respect to x. First with respect to y, then with respect to x. First with respect to y square with respect to y, minus derivative of y with respect to y is 1, then dy by dx equal to derivative of sin x is cos x. So dy by dx is cos x upon 2y minus 1, cos x upon 2y minus 1. This is the wanted derivative. The same example, my friend, given. The examiner doesn't want to give this big show. He wanted brief. What is that? Find dy by dx if y equal to root sin x plus y. Sin x plus y means this. Then you have to find which same. you have to square, bring y this side, same thing. If you wanted for diy, they may give here y equal to, it is root tan x plus 1 square. Derivative of tan x is x square. They may give log x, they may give e to the power x, anything they may give. Yes, my friend. These are some 11 examples, my friend. 11 examples on implicit functions. Implicit functions. All these 11 examples important under 2 mark. Just if you go through the model question papers very recently given by the PUC board, under 2 mark you have 3 examples, my friends. Under 2 mark, in every question paper contains what? 3 examples under 2. But among the 3, one is compulsory. I have seen model question papers 1 and 2, that this example on implicit normally they have given. Therefore, almost 2 mark questions, even though they feel a little bit lengthy, but they may 1 or 2 steps lengthy, that's all, my friends. Okay, they may give. Otherwise, they are good examples of 3 mark. Otherwise, they are good examples of what even CET also, my friends. CET. Yes, this finishes with implicit functions. Implicit functions. After finishing, I want to do some 3-4 examples on 2 mark questions on logarithmic differentiation. On logarithmic differentiation, my friends. We have done this as a big chapter there. Main exam I have done. Now I have taken only very few samples of what? 2 mark questions. Very few samples of 2 mark questions. Yes. In that case, if u and v are functions of x, and if y equal to, this is given, my friends. The form of the function is given. Y equal to e to the power y. You mean, in this case it is given y is what? One function to the power another function. In this case it is given one function to the power another function. In this case, in finding dy by dx, or to find dy by dx in this case, first take log to both sides. Log y equal to log u to the power v. Log y equal to log u to the power v. First take log to both sides, then differentiate both sides with respect to x. So, when you have y equal to one function to the power another function, in such cases, before differentiating, first to take log to both sides. First to take log, then differentiate both sides with respect to x. Remember, my friends. This is the property of logarithm. Log u to the power p. This power becomes coefficient. P log u. Power becomes coefficient. See, if it is u to the power p, my friend, if it is u to the power p, if you take log here, it becomes what? This power comes out, p log u. Now what is this, my friend? Y equal to u to the power p. Log y is log u to the power v. What is the power v? Log of the base. So remember, if you take log to this, power into log of the base, power into log of the base. So log y equal to log u to the power v. To avoid it directly, you can write power into log of base. Log of base. You can write direct, my friends, that. You can write direct. Right. Now, while doing examples, we get such form. Derivative of log y with respect to x. Derivative of log y with respect to x. First log y with respect to y, then y with respect to x. What is the derivative of log y? 1 by y into dy by dx. Next is, already I have reminded once again, what is it? Derivative of u v, product formula, what is it? First function as it is into derivative of second, plus second function as it is into derivative of first. This is product formula. Again, while doing examples on logarithmic, we use this formula. Product formula. Yes, my friends. So, while doing examples on logarithmic functions, there is one function to the power, another function. Take first log to both sides. Log y equal to log u to the power p. Use this property. That power comes as a coefficient p log u. Power into log of the base. Power into log of the base. Log u. Log u. Yes, my friends. So remember it. And I do simple examples which comes under 2-mark questions. Simple examples comes under 2-mark questions. 2-mark questions. Yes, my friends. Now I do some examples based on logarithmic differentiation. Logarithmic differentiation. Yes, my friends. These are some examples on logarithmic differentiation. See, differentiate x to the power x it is differentiate x to the power x with respect to x. Let y equal to x to the power x. Take log to both sides. Log y equal to log x to the power x. Apply that. Which one? This. Log u to the power p is that p comes outside. Log u base. That p comes outside. This power is x into log of the base. They say here. This is p into log of the base, log u. So it is log x. Differentiate with respect to x. Derivative of LHS equal to derivative of RHS. Log y other than x. First differentiate log y with respect to y, 1 by y. Then derivative of y with respect to x. While differentiating this RHS, it is a product of two functions. X is one function, log x is another function. Use product formula. First function as it is into derivative of log x. Derivative of log x is 1 by x plus log x into derivative of x is 1. Derivative of x is 1. That x cancels with x, my friend. Therefore, dy by dx equal to this y into 1 plus log x. What is y? X to the power x. Y is x to the power x. Therefore, dy by dx equal to x to the power x into 1 plus log x. This is the derivative of x to the power x. Good example under 2-mark question, my friends. 2-mark. What you have to do? Let y equal to x to the power x. Take log to both sides. Log of LHS equal to power into log of the base. Power into log of the base. X log x. Differentiate. Derivative of LHS equal to derivative of RHS. Log y. First with respect to y, then y with respect to x. Product formula uv. First into derivative of second log x plus second into derivative of x is 1. So dy by dx is y. X cancels 1 plus log x. Substitute the value of y. X to the power x into 1 plus log x. Same it is one more. X to the power sin x with respect to x, where x is positive, where also my friends x is positive. To avoid what? 0 to the power 0 is undefined. If x is 0, it becomes what? 0 to the power 0, which is a indeterminate form. To avoid it, my friends, x should be positive. X should be positive. X is positive because here also, if x is 0, 0, sin 0 is 0. To avoid, x is positive. Let y equal to this. Take log to both sides. Log y. Power into log of the base. X, log x. Differentiate with respect to x. Derivative of LHS. Derivative of this product. 1 by y into dy by dx. First function into derivative of second. Derivative of log x is 1 by x plus log x into derivative of sin x is cos x. Yes, dy by dx equal to this y. Down becomes numerator. sin x upon x plus log x into cos x. I have written cos x into log x. Substitute the value of y. What is y? X to the power sin x. X to the power sin x into sin x upon x plus cos x log x. This one. This is second example. Same third. Third is here. Differentiate x to the power log x. X to the power log x with respect to x. Let y equal to x to the power log x. Taking log to both sides. Log y equal to log. It is what? X to the log, x to the power log x. Yes. Power into log of the base. Log x into log x is what? Log x the whole square. Differentiate derivative of log y. D by dx of log x to the power 2. 1 by y into dy by dx. Fx to the power n into fx to the power n minus 1 into derivative of f log x. It is 2 log x into derivative of log x is 1 by x. So dy by dx is this y. What is it? 2 log x upon x. What is the value of y? X to the power log x into 2 log x upon x. 2 log x upon x is the respective derivative of this. In this case, it is quite simple. We avoided what? That UV formula. We have to make use of x to the power n. It is a log x to the power 2. Yes, friends. 1 minute copy. 1 minute copy. 1 minute copy. These you try, my friends. These you try. Same parallel examples, my friends. These are DIY. Copy DIY. First one. Log x to the power x. Second one. Sin x to the power cos x. Third one. Log x to the power cos x. Fourth one. It is sin x to the power x. Sin x to the power x. These are also comes under 2 mark questions. 2 mark questions. Even it is slightly lengthy. X plus 1 by x to the power x. All these we have done for what? The main video. I am doing this is a repetition, my friends. Already all these examples are there in previous videos. They are separately chapter wise I have done. Here mixed 2 mark questions I am doing. Copy it, my friends. My friends, there are 2 examples. They may ask for 2 mark question. If they feel lengthy, they may go for what? 3 mark questions. And these are either 2 mark, otherwise 3 mark, my friends. Both examples. This as well as this also. 4th and 5th. Find dy by dx if x to the power y equal to y to the power x. Y to the power x. 50-50. 2 mark, otherwise 3 mark. Good example. Given x to the power y equal to y to the power x. Take log to both sides. Log of LHS equal to log of RHS. Power into log of the base equal to power into log of the base. Differentiate both sides with respect to x. Derivative of LHS equal to derivative of RHS. Product function UV. Product first into derivative of second log x 1 by x plus log x into derivative of y dy by dx. It is a product formula for LHS. Now for the RHS equal to x into derivative of log y first with respect to y into dy by dx plus log y into derivative of x is 1. Simplify it. Collect dy by dx one side. Log x into dy by dx. This plus becomes minus x by y into dy by dx equal to log y minus, this is free from dy by dx, minus y by x. Y by x. Dy by dx is common. Log x minus x by y. Minus x by y. This side LCM x. LCM x cross x into log y minus y upon x. This also, y is LCM, y log x minus x upon y into dy by dx equal to x log y minus y upon x. Solve for dy by dx. Dy by dx equal to a by b becomes b by a, y upon x, or it is y into numerator x log y minus y upon x into this numerator will go to down denominator y log x minus x. The same thing is written. Therefore, dy by dx equal to denominator y into RHS numerator upon x denominator of RHS into what is it, numerator of LHS, that is y log x minus x. This is the required dy by dx. 50-50 man, it may come under 2 mark, otherwise 3 mark question. 1 or 2 steps more. This side is same, product formula only there, log y instead of log y, it is a product formula there. This is one really a very strange example it is. If x equal to root a to the power sin inverse t and y equal to root a to the power cos inverse t, then show that dy by dx equal to minus y by x. Minus y by x. X is this, y is this. Prove that dy by dx is minus y by x. Take the product of it, x into y. X into y is what? Square root a to the power sin t into square root a to the power cos inverse t. Now you have to make use here, my friends, this property of surd. Root a into root b, you are going to write what it is. Root ab. Formula, surds. Rules of surds. Yes. Root a into root b is root ab. Have a common square root. This into this, but bases are same. Bases are same. Laws of indices. Add powers. Sin inverse t plus cos inverse t. But what is sin inverse t plus cos inverse t? By property of what? Inverse trigonometric functions. It is pi by 2. So, your simplification that RHS leads to square root a to the power pi by 2, which is a constant. I have written once again. Therefore, LHS is xy equal to RHS is square root a to the power pi by 2. Differentiate with respect to x. Derivative of LHS equal to derivative of RHS. Supportive step. It is a product. First function into derivative of y dy by dx plus y into derivative of x 1. This being a constant, its derivative each here. Shift plus y minus y. Shift y into becomes division. So dy by dx is minus y by x. Dy by dx is minus y by x. So in this case, the secret, you have to take what? Product x into y. Root a into root b. Root ab. While taking root ab, base is same. Add the powers, laws of indices because of this property. Then this is power is pi by 2 by property done in inverse trigonometric functions. Therefore, x into y equal to constant. Differentiate with respect to x. Derivative of xy equal to derivative of RHS. Product formula equal to 0. Shift minus y. Solve for dy by dx minus y by x, which is we wanted, my friends. These are some selected examples under 2 mark question. Only if you needed this when y equal to this is x sine 3x product formula. In this case, you have to find what? dy by dx. find d2y by dx. If 1, y equal to x sine 3x, x sine 3x, it is 1. X sine 3x, this is 1. Second is one more. Second is y equal to, this is x cube log x. If wanted one more, it is e to the power x into cos 3x. Yes, in this case, my friends, you have to make use product formula. Product formula. You have to find d2i by dx2. You have to find d2i by dx2. Yes, DIY. DIY. These are some examples, my friends, under 2-mark questions. Under 2-mark questions, we have done logarithmic. Sometimes the friend may go with what? Examples done under what? ITF. That is, find dy by dx if y equal to sine inverse 2x upon 1 plus x square. Put x equal to tan theta. Such type. Another 2-3 examples will come. Inverse trigonometric functions. Y equal to sine inverse 2x upon 1 plus x square. Cos inverse 1 minus x square upon 1 plus x square. Tan inverse 2x upon 1 minus x square. Some such very simple examples they may ask under inverse trigonometric functions under 2-mark questions. But they are not given for your model question papers, my friends. Model question papers given by PUC board. 2 papers they have given. In that, we have selected these examples. Successive, logarithmic, implicit, and whatever I have done, my friends, whatever I have done. These are some selected examples. Yes, my friends, this is enough. This is enough. So, next man, we will go 2-mark questions with a next. If this differentiation is completed, I will start with integration. First I do 1-mark questions, then I do 2-mark questions on integration. Then I go for what? Applications of differentiation. That comes under 2-mark question. Applications of 2-mark derivatives. That to tangent to normal only. Yes, some examples I do. Okay. Yes, my friends. Till then, bye, goodbye, namaste, namaskara, namashinya. Good day, my friends. Thank you very much. Thank you.